Welcome back to the solutions manual. In this video, we will solve the problem 2-77 from RC Hibbeler Engineering Statics 12th edition. According to this problem, we have to determine the magnitude and coordinate direction angles of F2 so that the resultant of the two forces is 0. Now to solve this problem, first of all, we have to resolve each of the forces into their components. So for the F1 force, I have to draw its projection on the xy plane, and it would look something like this. So this right here is F1 cos 15, and now I have to resolve this projection along the x and y axis. So this is the component along the y axis, and this is the component along the x axis. So let's label them. This right here is F1 cos 15 into cos 60, and the x component is F1 cos 15 into sine 60. Also, we have a vertical component in the negative z direction, and it would be F1 sine 15. The F1 force in terms of Cartesian vector form can be written as F1 cos 15 into sine 60 I plus F1 cos 15 into cos 60 j. Since the z component is in the downward direction, so negative F1 sine 15 k. When I substitute the values, it would be F1 is 180 newtons. So 180 into cos 15 into sine 60 I plus 180 into cos 15 into cos 60 j minus 180 into sine 15 k. So upon simplification, F1 comes out to be 150.57 I plus 86.93 j minus 46.59 k. Now for the F2 force. The F2 force is represented by the coordinate direction angles. So F2 force in the Cartesian vector form can be written as F2 cos alpha 2 I plus F2 cos beta 2 j plus F2 cos gamma 2 k. Since the resultant of these two forces should be 0, if I find their vector sum, then they should add up to 0. So 0i plus 0j plus 0k. Let's call this equation 1. So if I substitute the values of F1 and F2 in the equation 1 would become, for the F1 force we have 150.57 I plus 86.93 j minus 46.59 k plus F2 cos alpha 2 plus F2 cos beta 2 plus F2 cos gamma 2 equals to 0i plus 0j plus 0k. So now we are going to compare the I, j and k components. So comparing I, j and k components. So for I component, so we have 150.57 plus F2 cos alpha 2 equals to 0. And if I rearrange this equation, it can also be written as F2 cos alpha 2 equals to negative 150.57. So let's call this equation A. For J components, we have 86.93 plus F2 cos beta 2 equals to 0. And if I rearrange it, it would be F2 cos beta 2 equals to minus 86.93. So let's call this equation B. So now for K components, we have negative 46.59 plus F2 cos gamma 2 equals to 0. And if I rearrange this equation, it would be F2 cos gamma 2 equals to 46.59. Let's call this equation C. Now, we have to find the magnitude of the F2 force. So for the magnitude, of F2 force, we can find the magnitude by using the Pythagoras theorem. So we have F2 is equals to square root of F2x square plus F2y square plus F2z square. So this is the F2x, this is the F2y, and this right here is the F2z. So if I substitute the values, I would have F2 is equals to square root of F2x, which is negative 150.57 square, plus F2y, which is negative 86.93 square, plus F2z, which is 46.59. Square. So upon simplification, F2 comes out to be 180 newtons. This is our first answer. And now for coordinate direction angles. Put F2 equals to 180 newtons in equation A, B, and C. For alpha 2, consider equation A. So from equation A, so we have cos alpha 2 is equals to negative 150.57 divided by F2, which is 180. So if you take the cos inverse of negative 150.57 over 180, then you would get alpha 2 as 146.8 degrees. This is our second answer. Now for beta 2, we can consider the equation B. So from equation B, we have cos beta 2 equals to negative 86.93 divided by F2, which is 180. So again, if you take the cos inverse of negative 86.93 over 180, then you would get the B2 as 118.9 degrees. So this is our third answer. Now we have to find the gamma 2. So for gamma 2, we have to consider the equation C. So from equation C, cos gamma 2 is equals to 46.59 divided by F2, which is 180. So if you take the cos inverse of 46.59 over 180, then you would get the gamma 2 as 75 degrees. So this is our fourth answer. So this is it for this problem. I hope you would find this video helpful. If you do, please make sure to subscribe to this channel and also turn on the bell icon for the daily updates. And if you have any questions or any doubts, then feel free to ask in the comment section and I will answer it as soon as possible. Thank you.